So hello everyone, and I hope everyone in my 502 class is okay and hanging in there. A lot of us have possible jobs on the line and health issues on the line. This is a very scary time for everybody, as you're well aware. So I just hope everyone is well. Okay, so someone had a question on chapter, I believe it was chapter 5, problem 12 here. And it's actually B5-3. Many academic institutions offer a sabbatical policy. Every 7th year, a professor is given a year free of teaching and other administrative responsibilities at full pay. Okay? So, by the 7th year, you get that. So for a professor earning $70,000 per year who works for a total of 42 years, now, $70,000 a year for 42 years, that's going to be 6 sabbatical periods, right? What is the present value of the amount she will earn while on sabbatical, right? Total amount, right? If the interest rate is 6% effective annual rate. Now, let's understand this. This is almost like a lotto problem, okay? This is like a lotto problem. Remember I said you take the present value of the payments for lotto, and it's always going to be less than the sum of each one. Remember you say I'm taking the lump sum? So this is a lump sum problem, just like lotto. We're going to take all her sabbatical payments and figure out what's the lump sum equivalent after 6 years, right? There's a sabbatical for this 7th year, for that 7th year, for that 7th year, that 7th year, that 7th year, and that 7th year. Okay? So the question is, basically, what is the present value of the 7th year payments she's going to be getting, okay, over these 6 periods? Okay, she gets a payment, she gets a sabbatical payment the 7th year 6 times. So we're basically going to take the 6 payments and get the present value, just like we do with lotto, okay? So I'll show you the equation problem first. This is an excellent problem, and the person who sent it to me has excellent points. Okay, now we need the effective rate. We need the rate over the 7 years. Okay, I believe this is equation, if I'm not mistaken, 5.1 in your book. We need the discount rate, okay, over the 7 years, okay, to figure out what is the equivalent interest rate that we're going to use to calculate this present value. So if it's 6% per year and we go out 7 years, right? There's 7 years in each payment, right? This is going to be 1 minus 1 plus 0.06, which is given to, now this is 7 years in each period here, right? So we're going to get the interest rate for each 7-year period. So this is the equivalent interest rate for each 7-year period. It's 50.363%, okay? Now, so that's 6% a year for over 7 years, and it's like you're getting this interest, okay? All right, so that being said, we have that interest rate. Now, all we need now, since we've got that, now we have that for each one of these 7-year periods. So we're basically done. So now we just take the present value, okay, of an annuity. This is the present value of an annuity because we're going to get 6 payments over this each sabbatical, okay? So here's my payments over the sabbatical, $70,000, and again, pretend this is like a lotto problem where they said you're going to get $70,000 a year for hitting lotto, okay? But now, so here's the interest rate we calculated up here for each period, each 7-year period, okay? So this rate goes with each one of these periods as we see. All right. Now, you notice this is 7 here because we were getting the interest rate for these each 7 years, but now we got 6 7-year periods. So now we have 6 periods. So this is like winning $70,000 a year for 6 years, and they're saying, what is the equivalent lump sum if I wanted to take that all today up front? Okay, so that's what that is. And basically, when you solve this equation with this as the annuity amount, and you use this interest rate, it comes out that it's like you won a lotto, and they're going to give you $126,964 up front. Okay, this whole first part was to get the interest rate equivalent for each 7-year period. Now let me show you this in Excel, if you don't mind. Let me just get this out of the way if I can. Let me see if I know I had the Excel one. Here's the Excel one. All right, let me just move that up. So again, here's the 6 years, the 6 periods of 7 years each. You'll notice this goes like 42 years. All right. So you're getting $70,000 payment, okay, from year 7, and then year 14 you get a $70,000 payment, right? The end of each year, and that goes on and on. So for basically, at the end of the 7th year, at a rate of 6%, if you basically had $1 today, in the future you would accumulate $1.5363. This is telling you that you basically have an interest rate here, as they show here, of 50.363, as you saw in equation 5.1. Okay, so we calculated this, and now we do it in Excel, and you can see that. Okay, now that we have that interest rate, which is all we needed, now we got to do the lotto portion. So we do the lotto portion. So we have 6 7-year periods at this rate, okay? And basically the payment was $70,000, as I said, in lotto. That's why it's a payment. You're getting $70,000, okay? And when you solve that, it's equivalent to getting $126,964 as in the calculation. So what's happening here is they said, pretend that you have a lotto and you were getting $70,000 a year at this interest rate. What is the equivalent present value lump sum that you would take today? Okay, and that's what they're saying. I hope I'm clear. If I'm not clear, always feel free to email me. This was a really difficult problem, and a lot of thought had to be given into it. Okay, thanks everybody.